Having previously learned how to solve systems of equations with elimination, we are now going to try to go one step further. If you recall from the last video, solving systems with eliminations means adding two equations together with the goal of eliminating either the x or the y so that the other variable can be solved. Generally, when you add the two equations together, either the x will be opposite coefficients and they will cancel out, or the y will have opposite coefficients and will cancel out, making 0 so that that variable drops completely out. But looking ahead, if we were to add these two equations together, if we added a negative 2x plus a 7x, we would get 5x, not 0. And if we were to add 15y and negative 5y, we would get 10y, again, not 0. As a result, we have a problem here. We can't solve it with elimination because we're not eliminating anything. So we need to think back to our Desmos activity from class. Because what we're going to need to do is we need to change the numbers in the equation. We need to change the way the equation looks without changing its value, without changing the equation's value. In other words, we need to keep it equivalent. And we learned how to do that in class with our Desmos activity. Now remember, you can pause this video to get caught up. You can play it slower at a slower speed. You can play it at a faster speed, whatever works for you. Okay, I'm going to go back to what we were talking about with our Desmos activity in class. Okay, so we had this one equation, x plus 2y equals 4. And we graphed it. And we noticed that it had an x-intercept of 0, 2 right here. Every time we go down 2, we go over 4. Every time we go down 1, we go over 2. So we have a negative 1/2 slope going on here. And we wanted to see what would happen if we made a new equation by multiplying the equation by, let's say, 2. So that's what we did. We multiplied 2 times x, which gave us 2x. We multiplied 2 times 2y, which gave us 4y. And we multiplied 2 times 4, which gave us 8, and that gave us an entirely new equation. Different coefficients, different numbers. 2x plus 4y equals 8. And what we noticed was that this graphs right on top of our first graph. It too has a y-intercept of 0, 2. It also has a negative 1/2 slope, a rise of -1, a run of 2. So even though this equation looks different, has different coefficients, it has a different constant, it is entirely equivalent. Okay, it looks different, but it is equivalent to the first equation. And we tried it with a whole range of numbers. We tried it with 3, which gives us 3x. 3 times 2y is 6y. And 3 times 4 is 12. Let's try graphing that one. 3x plus 6y is 12. And again, it graphs right on top of the other two. Same y-intercept, same slope, it is equivalent. We wondered what would happen if we used a negative number, so let's try negative 5. Negative 5 times x is negative 5x. Negative 5 times 2y is negative 10y. Negative 5 times 4 is negative 20. And we graph that. Negative 5x minus 10y equals negative 20. And lo and behold, graphs right on top. So this Desmos activity that we did in class basically showed us a new way to write equivalent equations, equations who have the same value even though they look different. So we use this then when we're solving with elimination. In other words, I need to make one of these variables, the x or the y, cancel out. So let's just look, for example, at these two y coefficients, positive 15 and negative 5. Like I said, if I add them together, they don't equal 10y, or they don't equal 0, they equal 10y. However, what can we transform $15y to? Let's scratch that. Let's say, what can we add? What can we add to 15y to cancel it out? What can we add to 15y to cancel it out? Well, the answer to that is we can add negative 15y. Correct? Correct. 15y plus negative 15y is 0, canceled out. So, how can we change negative 5y to negative 15y? Think about the answer to that. How can we change negative 15y? I'm sorry, negative 5y to negative 15y? Well, we can do it by multiplying by 3, right? So let's try it. We're going to multiply. Well, if we're going to multiply this negative 5y by 3, what do we have to do to keep the equation equivalent? We have to multiply the whole equation by 3. So let's try. We're going to multiply this whole equation by 3. 3 times 7x is 21x. 3 times negative 5y is minus 15y, which is what we wanted. And 3 times 17 is 51. So now we have a new equation that is completely equivalent to our old equation, but it looks different. Let's just take the first equation and rewrite it. So that would be negative 2x, negative 2x, sorry about that, plus 15y equals negative 32. So I just took this equation and rewrote it, brought it down, didn't change anything. We only changed our second equation. And now I can perform the elimination. I can add them together and I will have one of my variables cancel out and make a 0, which is what I wanted. So negative 2x plus 21x is 19x. Negative 32 plus 51 is 19. X equals 1. Okay. Now it proceeds the same way that it did before. We just need to take this x equals 1 and put it up here. Instead of writing 2 times x, we write 2 times 1. So 2 times x, well, let's just rewrite the whole thing. So we're rewriting it again. You don't have to do all this rewriting, but if it helps you understand the flow of things, where you're going, feel free. We're going to plug in the 1. So 2 times 1. 2 times x is 2 times 1. Okay. 2 times 1 is 2. And we're just going to use our old inverse operations that we've gotten really used to using by now. Look what I've done. That's supposed to be negative 2x. So that's supposed to be a negative 2. So I'm supposed to add 2. And I get negative 30. Copy carefully. Because when you don't copy carefully, you do things like that. I drop that negative sign. Changed my whole problem there for a minute. So it's negative 2x plus 15y equals 32. Negative 2 times 1 is negative 2. Negative 2 plus 2 is 0, canceled out. 15y equals negative 30. And y equals negative 2. So now we found our x and our y, which is what we're trying to do to begin with. So our xy pair is going to be 1, comma, negative 2. Okay, our xy pair is 1, comma, negative 2. That's our answer. All right, that's our final answer. Okay, so I've got one for you to try like I always do. If you need to go back and rewatch this, that's fine, however many times you need to. In order to figure it out, see what you can get when you try this problem, bring it back to class. Make sure you've copied everything carefully so that you are ready for a homework quiz. We'll go over the You Try in class on Monday. See you Monday.